students, welcome to Competitive Exam Library YouTube channel. Today we are going to see what is the expression for maximum peak overshoot. Maximum peak overshoot in the second order system whenever you are applied the a unit step input. So we are already know what is the response you are going to get whenever you apply a unit step input for the second order system. That can be written as 1 minus e to the power of minus zeta omega nt divided by under root of 1 minus zeta square into sine of omega d t plus theta. This expression we are already know. This you consider it as equation 1. So whenever you consider like this, what is the expression we are going to write for maximum peak overshoot? I already shown here what is the peak where you are going to calculate the peak overshoot. So the peak overshoot value will be calculated at t is equals to tp value. Then that is the difference between c of infinite to c of t. So the maximum value at t is equals to tp, what is the values? That is, we have to take c is equals to tp and c of infinite. The difference between these two we are going to call it as that is maximum peak overshoot. So let us do the derivation for that. So whenever you have taken like this, so now we are already know from the diagram you can say this c of t is occurring at t is equals to tp. At t is equals to tp, what is the expression we can write? That is c of tp is equals to 1 minus e to the power of minus zeta omega n tp divided by under root of 1 minus zeta square sine of omega d tp plus theta. Just I have substituted. This is the equation number 2. So you are already know what is the peak time formula. That will be pi by omega d, or that is also we can write pi by omega n into under root of 1 minus zeta square. Let us substitute that c of tp in the equation, that is tp equation in the equation 2. 1 minus e to the power of minus zeta omega n. Tp value can be written as pi by omega n into under root of 1 minus zeta square divided by 1 minus zeta square into sine of omega d. Tp value can be written as pi by omega d plus theta. So if you write that omega n and omega n will get cancelled, that will be 1 minus e to the power of zeta pi divided by 1 minus zeta square divided by 1 minus zeta square into sine of, here also omega d will get cancelled, pi plus theta you are going to get. Then you can more simplify what is the sine of pi plus theta can be written as, that is minus sine theta. From the trigonometry we can substitute that. Then what you are going to get, 1 plus we can write that as 1 minus e to the power of minus zeta pi divided by 1 minus zeta square divided by 1 minus zeta square into minus sine theta. So just I have substituted sine pi plus theta as minus sine theta. Next we can more simplify that as c of tp, we can write it as 1 plus e to the power of minus zeta pi divided by 1 minus zeta square divided by sine theta into, sorry, here it is not going to get the sine theta. So under root of 1 minus zeta square into sine theta. So we are already know the expression for the sine theta from the triangle, that is equals to 1 minus zeta square. That means this one will get cancelled. So we can write c of tp is equals to 1 plus e to the power of zeta pi divided by 1 minus zeta square. Now you got the c of t. So what we can write, the c of t value will be, that is equals to, we can write this as c of t is equals to this one. So whenever you have taken c of t value, then tp value, we don't want c of tp value, we want the what is the mp value. So we can write maximum peak overshoot will be given by maximum peak overshoot is given by that expression, that is equals to, we can write MP is equals to C of Tp minus C of infinite. So we can write that as, that is equals to 1 plus e to the power of minus zeta pi under root of 1 minus zeta square minus 1, plus 1 and minus 1 will get cancelled. MP you are going to get it as e to the power of minus zeta pi divided by under root of 1 minus zeta square. So where C of infinite is equals to 1, which is a final value. So this is the final value of the expression. Now you got the maximum peak overshoot. If you want to express this maximum peak overshoot in percentage, percentage peak overshoot is given by, we can write that is percentage MP is equals to C of Tp minus C of infinite divided by C of infinite into 100. So what you are going to get, C of Tp value, that is equals to 1, C of Tp value we got it as, that is, so whenever you have taken C of Tp value, what you got, 1 plus e to the power of minus zeta pi divided by 1 minus zeta square minus 1 divided by 1 into 100. That is what we are substituted. Plus 1 minus 1 will get cancelled. So finally we can write maximum peak overshoot when it is expressed in terms of percentage, we can write as e to the power of minus pi zeta divided by 1 minus zeta square into 100. So this is the answer for peak overshoot. How you are going to get the value will be, the value is here is peak overshoot, the value is here peak overshoot here. So this is the value of expression for the peak overshoot whenever you are expressed in terms of percentage. The same thing whenever you are expressed in terms of only values, that you can write it as this is only value here. So this you can write as the value will be, this is the value of the peak overshoot. Now whenever you are having a strength, so whenever we draw the variation of the graph, so let us draw the variation of, we will draw the variation of peak overshoot with damping ratio. So whenever you are that means whenever you draw the peak overshoot variation, then what you are going to get, the expression, sorry, that the graph will be, whenever you draw the graph, it is going like this. See, let us draw the graph with of this expression, then what you are going to get, see, this is the, we are going to take MP value and with respect to the variation of zeta here, the graph if you observe, so MP value is, it is exponentially decaying, we can say it is exponentially decaying, we can say, that is like this, slowly it is decreases like this. So what is the expression we got, e to the power of minus pi zeta divided by 1 minus zeta square. This is the expression we got when it is subjected to, the input is subjected to a unit step. Otherwise if it is subjected to a strength of A, so when it is subjected to the strength of A, that is the second order system, when it is subjected to strength of A, then what it will become, C of Tp will become, that is equals to A into 1 minus e to the power of zeta pi divided by under root of 1 minus zeta square. So C of Tp, sorry, 1 plus here, so you are going to get C of Tp will be like this. Next, what is the maximum peak overshoot, that will be A plus A into e to the power of minus zeta pi divided by 1 minus zeta square minus A, so A will get cancelled. So maximum peak overshoot, in this case you are going to get A into e to the power of zeta pi under root of 1 minus zeta square. This is the expression for strength of A whenever you apply. Whenever you want to express in terms of percentage maximum peak overshoot with that strength, then what you are going to get, simply So a into e to the power of minus zeta pi under root of 1 minus zeta square, that is a plus, first you are going to get minus a divided by a into 100. So whenever you take that, a and plus a minus a will get cancelled, and here a also will get cancelled. Maximum peak overshoot will be given in this case also, e to the power of zeta pi under root of 1 minus zeta square into 100. So whenever you want to express in terms of percentage, you are going to get the same thing. That's all in this video. If you like this video, please like, share and subscribe the channel. If you have any query, please make comment in the comment box. I can reply. Thank you.